Greg Troutwine with Offshore Engineer TV, and we're very pleased to be joined today by Dr. Anil Gill, Balmoral Offshore, to discuss Balmoral Comtec's solution to a well-publicized problem surrounding offshore wind cable failures. Dr. Gill, to start, can you give an overview of the problem that some offshore wind systems are experiencing with their cable systems?
Hi there, Greg. Thank you for that. So yeah, we can talk a little bit about that aspect. I think it's important to mention to the viewers that there's not a lot of data out there existing on the failure modes that have occurred within specifically the two articles that we're kind of referring to. So it's really difficult to actually paint an accurate picture of what happened, how it happened, what were the set of circumstances that led to that. What we can do, though, is as designers, as engineers, is look at this environment holistically and understand that there are some abrasion problems that can occur component level. There are some abrasion characteristics or issues that need to be dealt with from a scour to product perspective as well. And those are the things that we can kind of look at within our system and look to capture and try and design accordingly, you know, with those characteristics in mind.
As I said from the outset, we understand that Balmoral Comtec has a potential solution via its integrated cable protection stability system. Can you discuss the solution with insights on how it works?
Yeah, absolutely. So the system itself is built around a device, a segment that we call an SDU, which is I'll take away the acronym, so a standard dynamic unit. And this tubular structure is effectively a stiffener. It's a bend stiffener, which is well known within oil and gas industry for controlling curvature of cables and pipelines and umbilicals. Using that approach, what we're able to do is, unlike a vertebrae style system, which let's say is free to articulate and move until lockout, the bend stiffener style approach, or an SDU approach, adds stiffness to the line constantly throughout its curvature ranges, thus controlling the cable and controlling the movement. An additional feature that we believe adds a huge benefit is our stability system. And our stability system is, in essence, integrated ballast units which connect onto our CPS system and control the curvature even more by adding a dampening effect onto the system. So by adding mass, by adding these ballast modules, we're able to minimize the movement and the curvature of the system. And in doing so, when we minimize movement and when we minimize curvature, we inherently improve cable fatigue, wear, so wear component to component, and also wear of component to scour. So those are the kind of basic principles behind our CPS stability system, our cable protection stability system.
Okay, well, again, excellent, and thank you for that insight. So, if I understand correctly, this solution was not developed specifically for offshore wind per se.
Yeah, absolutely. I mean, the solution has been used in oil and gas as a method of stability on not just touchdown areas. So where you know you perhaps got a pipeline going into lazy S and then it's coming into the seabed contact area. And again, you want to stabilize the movement of that connection point. It also is used off the back of bend stiffeners. So we're talking now splash zone, a cable or a pipe or an umbilical coming through the water column. And if you have a very dynamic sea state, you perhaps at the further down from your bend stiff, you want to add some mass. You want to add again some stability there that dampens the effect of these dynamic motions. And that ethos, that methodology, that development of product, we've carried forward into the CPS system.
Okay, well, this kind of carries on our theme of taking proven technologies for offshore oil and gas and applying them to other fields, particularly the growing offshore wind market. Dr. Gill, you've been very kind with your time. I thank you.
No problem. Thank you very much.